Now we'll see what is the basis for deciding which type of shell to be used in a particular condition. So this is based on operating conditions again. Like the most commonly used one is the E-type shell. This is the E-type shell where you have the tube sheets welded to the shell on both the sides. So this is one tube sheet acting as a flange also. This is the other tube sheet. You have the inlet and outlet nozzles here. This is a typical representation. The reason why it is preferred is because these E-type shells can withstand, can be used where pressure drop on the shell side is not a constraint. You have adequate pressure drop available. So it is easy. It is good to use a E-type shell in that case. And these are also good to handle large temperature differences. But in such cases, you may need an expansion joint as a means of restraint relief. Next is where you have a case where you have the pressure drop constrained on the shell side. In such cases, it's recommended to use either a J-type shell or a G or a H-type shell. Now, what is a J-type shell? If you see in the TEMA classifications, there are two J-type classifications. One is what we call as a J12 shell, where you have one inlet nozzle and two outlet nozzles. So this is what we call as a J12 shell, and this is the fluid flow pattern. The fluid is split after it enters the shell, split on either side of the inlet nozzle and flows through the bundle across the tubes, affecting the heat transfer process. So as a J12, we also have a J21 shell, where you have two inlet nozzles and one outlet nozzle. Here, the splitting of the flow is outside the heat exchanger, and this is the flow path. So next we have the G-type shell, which is the split flow shell. You have the fluid entering through the inlet nozzle, going on either side of the nozzle through the longitudinal baffle, the split baffle we have in the shell, and coming out from the outlet nozzle. Similarly, the H-type shell is what we call as a double split shell. You have two inlet nozzles and two outlet nozzles, and each of them has a split flow baffle in the center. So the fluid flow path in this case is like that. So you have a split here, both external as well as internal. So each flow path is only accounting for around 25% of the total flow in a H shell. So effectively, by dividing the flow, we are able to ensure that we design a heat exchanger with a low pressure drop on the shell side, where we have such a constraint. Now, what do you do when you have a very low allowable pressure drop? Every fluid flow has pressure drop. And when you're talking about cross flow across the baffles, cross flow and counter current or co-current flow along the baffle due to the presence of baffles, you will have pressure drop which is substantially higher. So when you have very low pressure drop, allowable pressure drop on the shell side, the preferred unit to shell type to use is a X-type shell. A X-type shell is a pure cross-flow shell. There are no baffles in this shell. The blue lines which you're seeing here are the support plates only. These are only here to support the plates. The fluid flows, enters through the nozzles, gets distributed across this length and flows across the bundle to the outlet nozzle. For this reason, to ensure adequate fluid distribution along the length of the tubes, we have multiple inlet nozzles and multiple outlet nozzles in a X-type shell. The number of inlet and outlet nozzles would depend on the actual tube length which you decide to use for that unit, so that you have proper distribution of fluid across the shell. Yes. Now, there are many cases where you have a shell side fluid which is entering the unit as a liquid, either at saturation condition or slightly below saturation, and you intend to generate vapor on the shell side, vaporize the shell side fluid. So this is what we call saturated. You generate saturated vapor on the shell side. This is what we call as a pool boiling on the shell side. These units are generally used as the bottom heat exchangers in at the bottom of distillation columns to preheat the bottom feed actually. So in such cases, we recommend to use a K-type shell, which is what it's a kettle-type shell. So this is a kettle-type shell where you have the tube bundle and you have a larger shell, much bigger than the actual required shell diameter. So this is the kettle, and this is a transition piece between the tube bundle and the shell or the kettle. So the major requirement in a kettle type reboiler is that the tube bundle should always be submerged in a pool of liquid. So this wear plate serves to ensure that purpose. The wear plate always ensures that your liquid level is above the tube bundle, top of the tube bundle. And the space between the tube bundle and the inside of the kettle shell is the space where the vapor is rising, and it is also allowing for vapor to disengage from the liquid. Liquid droplets carry over and those can fall down. And additionally, these are generally provided with a demister pad, which ensures that any liquid droplet carryover would be arrested and the liquid droplets would come back into the shell. Now, exchanges are, many cases we provide exchanges in series or in parallel. Generally, exchanges are provided in series when your design is, when you're not able to meet your required heat duty within a single shell. It happens sometimes with that you have gone up to a very big shell diameter and you're still not able to meet your heat duty within a shell. It can happen even in smaller diameter cases, depending on your other operating parameters also. So to avoid exchangers in series, we can use what we call as a F-type shell. An F-type shell is where we have a longitudinal baffle on the shell. This effectively makes the heat exchanger as a two pass on the shell. You have if this is the inlet nozzle, the fluid flows across the longitudinal baffle and again reverses and comes back through the outlet. So it is traversing the shell twice. So it's making this as a two pass on the shell side. It is effectively the same as two exchangers in series arrangement. Having said that, F-type shells are also prone to certain problems. If you have a high pressure drop if you have a high pressure drop on the shell side because of this design, then you have chances of fluid leakage or even heat leaking across the longitudinal baffle. And to arrest fluid leakage, F-type shells are generally provided with what we call as sealing arrangements like 𝗵𝗵𝗲𝗃 seals, so that the fluid does not leak across the longitudinal baffle. So these seals are again prone to damage during maintenance activities. Once you pull out a bundle, it gets damaged, the seal has to be replaced. So general preference, many consultants and clients tend to avoid F-type shells, though that doesn't mean they're not used. We have done quite a few F-type shells with 𝗵𝗵𝗃𝗃 seals in the recent past actually. So this is just a summary of the preferred shell types we'd use in the different considering different conditions.